Low cost is something that you can do yourself like this, and to be able to deploy low cost Internet of Things for developing countries. Could you pass this, please? Could you pass around? So, first of all, we are all aware that the domain of Internet of Things could provide a lot of benefit to many applications. And we are mostly considering a very simple case where you need to monitor some kind of very basic parameters like temperatures or pressure or moisture level and so on, and you want to be able to send this information like 10 to 15 kilometers away. Okay, and this is the case of most of telemetry systems that we want to build. And when you do that, you do have a traditional way to send data. You can use GSM, GPRS, 3G, 4G, whatever you want, but you have to pay the subscription, and also you have a very high consumption, energy consumption. Okay, so if you're using, let's say, 2G, you about 200 to 500 milliamps. So there's a lot of new recent technology that happen right now, and most of them are based on what we call long-range radios. And these long-range radios are capable of sending data from 10 to 15 kilometers away without relaying. And then I will do that at the demonstration later. Oh, you didn't have it. Okay. So these radios are capable of sending data from 10 to 15 kilometers away. And you don't have to pay any subscription fees. This works on unlicensed radio spectrum, so you don't have to pay fees, you don't have to ask for authorization and so on. And what happens is, if you look at the energy consumption, you are at the same level than short-range radio technology.
Thank you for
like CP, thank you. 254, for example. But you are going much farther. The range here is about 100 meters. The range here is about 10 to 15 kilometers. Okay? So you might think that actually when you read that, you have all the building blocks to make IoT happen. You have maturation of the IoT market with a lot of nice products here. You have the needs here. You have the radios. And then you may have to plug some data analytics on top of that. But when you think about it, when you want to deploy it in developing countries, you have to be aware that actually you are lacking infrastructures. You have a very high cost of hardware. I mean, who is going to buy this in a developing countries? If it's going to cost, let's say, 50 euro per device, and you want like 10 devices, it's already 500 euro. And this is a lot in developing countries. So if you want to make IoT happen in this kind of countries, you have to be aware that the cost of the hardware can be a very high limitation. And then you have to consider the complexity in deploying your own system. And of course, most importantly, you lack the technological ecosystem and background to build yourself this kind of infrastructures. So what we want to show that this picture here could happen in, let's say, developed countries, in Europe or North America, for example. But if you want to have these kind of things happen in developing countries, you have to find new ways to deploy and build your system. Okay? So, of course, you have the maturation of the IoT market, but here it is not really adapted. So, fortunately, we do have a nice do-it-yourself ecosystem. We have powerful board that you can buy for very cheap. Here you have the Arduino Pro Mini. So this is approximately the size. Maybe you didn't pay attention, but the whole thing is based on this kind of microcontroller. Okay. How much do you think it costs?
It's about 10 euros. 10 euros?
8 euros?
10.
10? Less than that.
3 euros?
The normal of 20 euros.
Less than that.
3?
Less.
Oh.
A little bit more.
One and a half.
You're right. 1.5. From Chinese manufacturer. I order 100 of them. It cost me 150 euro for 100 of pieces like this. Okay. So this is really very low cost. Okay. So you have a whole ecosystem where you have many of these kind of boards. So this is the kind of board that I'm using for integrating this kind of low-cost Internet of Things. But you can use all the boards to prototype, to test your solution before integrating and deploying the whole system. Okay? So we are integrating many radios. We are testing many boards. And actually what we're proposing is a long-range communication libraries that can take into account all these radios, all these boards, for you to deploy very easily your applications. So what we want to do is to make generic sensing IoT device where you can take this kind of board here, take sensors, and then from this board with the sensors, we can have several applications that you can, where you can deploy your system. So this is some kind of pictures of the Arduino Pro Mini. We buy them, and then we build it ourselves, and then we connect the radios, and then we put it in a nice box like this. And the whole thing like this is going to cost about 15 euros. The highest cost is actually the radio. The radio is about 8 to 10 euros. Okay, and then you have free 1.5 euro the battery pack and so on. So you can have something like for 15 euro approximately. Okay, and so I'm going to skip this. And we provide ready-to-use templates where we have the physical sensor management, security, long-range transmission, duty cycling, low power, logical management. And you can provide your own physical sensor reading if you want to plug your own sensors. Okay, you just have to write 5 or 6 lines of code saying what are you going to measure and how I'm going to transform this measure into something that I can understand. Okay, so once you do it, you can just get our software, upload it on the sensor, and it's going to work out of the box. And the nice thing is we integrate low power management. So we have 4 AA battery here. Okay. This one has been programmed to send 1 measure every hour. Okay. And we are capable of running for more than a year with 4 AA battery, with low power, duty cycling, and so on. Okay. And once I power it on, like this, it's going to send the temperature, because I have a sensor, a temperature sensor here. It's going to send the temperature to a gateway. Okay? So the gateway is on the desk over there, but you have to imagine that the gateway can be far away from the sensor, because that's the whole objective. So in urban area, it could be 2 kilometers away. Okay? And in line of sight condition, let's say countryside, it could be 10 to 15 kilometers away. Okay? So if you want to measure something like temperature in a storage area, you just have to put that somewhere. Okay? Switch it on. It's going to work for more than a year. And then you get in real time the data on your gateway that you can push on the internet and do whatever you want with this. Okay, so you just have to imagine this kind of scenario. Here I'm like 20 meters away, but it's also walking kilometers away. And the whole system needs a gateway, of course, because this kind of radio technology means that you are sending from one device to a gateway. And you can have several devices, of course. Like you can have 200 devices sending to the same gateway. Okay? So the gateway we are building is also a low-cost gateway because we base on Raspberry, all models of Raspberry, using the same kind of radio devices. So you can see all the steps here. And the gateway costs less than 50 euros. So if you have, let's say, 10 devices, one gateway, you have a whole system for less than, let's say, 200 euros. One gateway, 10 devices. Okay? And we have designed the gateway to be very flexible and to be able to be customized according to the needs of every application, and especially being able to be customized by third parties, because the goal is to make technology transfer, and all these things we are providing. Okay, we are providing templates, and if you want to change something, you just have to change this layer here that is programming in high-level languages, so mostly Python languages. So in, let's say, a couple of minutes, you can instantiate the clouds you want to push the data to, and how you want your post-processing task to be managed by the gateway. So we provide also templates for various clouds. So once you receive the data, you can push in Freeboard, Dropbox, Feeware, Wolfstream, SensorCloud, Firebase, ThinkSpeak, and so on. And this is something that I'm going to show you later on when we move to the demonstration area. And actually, you can build completely out-of-the-box surveillance system.
And also scientific director of
the you have the sensing device, and then we have all the templates
and also
for recycling, low
director
power,
of the European Network of
and you just have
Incidents in
to
Solar System and Services SQ.
connect the sensors.
Mike is a very recognized international
you want water
personality,
quality, you want diesel
leading a lot
oxygen
of
sensor,
projects, innovation in different areas like
you want, what kind of sensors you want. You just have to put this in your sensor here, and then the gateway will get all the data, and you can get all the data on the clouds if you want to. And working in developing countries, we have to be aware also that maybe you have internet access with Wi-Fi, 3G, GSM, maybe, but maybe not. Okay.
In the process, what problems they have.
When we're traveling in
the moment
in Africa with our partners, actually they told us that internet is very difficult to get in the countryside. It's almost impossible to have a stable internet access. So what we also propose is the gateway can work in a completely standard manner. We have an embedded web page, so everything that the gateway is receiving is stored on a local MongoDB
information,
database.
whatever. This information is very widely stored.
It's also
in
acting
different
as a Wi-Fi
sources.
access.
So what you want.
So if you want to check, if you have a smartphone, you can just check. There's the Wi-Fi advertised by our gateway. Was up something? Okay, you can just connect to it.
And he's currently head of the research group Context-Aware Smart Services.
All the data that has been received by the gateway. And once the internet is up again, then the gateway will just push data to the internet again. Okay, so everything is saved on the local database. And also, if you want to interact with, let's say, an Android application, smartphone applications, we have a small prototype of an Android application that interact with Bluetooth, because we also have a Bluetooth dongle here to be able to interact either with Wi-Fi, either with Bluetooth with the gateway. Okay. So now, for those that are interested, we can just move.
So I will allow people, because we received 3 or 4
in real time the various components, and show you how the gateway is going to get the data and directly send it to the cloud. You want?
have the temperature sensor.
Yeah, this is a temperature sensor. If you have any questions before we move over there, just go ahead.
Karag Watatuba. I can pronounce the
Yes. Everything is open source, and we do have.
I can pronounce the name of the city. Try to.
Everything is described here. Everything is described. You have the software for the end device. We have the software for the gateway. We have tutorials, videos, and so on, and all of this. And maybe I forgot to mention, but okay, everything has been developed within the European project WASIA, that involved 5 countries in Africa and 5 countries in Europe. And it started in February this year, so it's going to end in 3 years. And the main objective is to be able to make technology transfer, so that local companies could take the technology and build their own Internet of Things devices according to the applications that they want to push. We are thinking of some applications, and we are demonstrating that we can build or we can certify these applications with our platform. But we can't think on all the applications that could be deployed. Okay, so we provide the software, we provide the platform, and then the local company will start building their own products. So this is the main objective of the project. More questions?
Which radio frequency do you use for the long distance transmission?
So most of these long-range radio technologies are working on the sub-gigahertz. So sub-gigahertz means below 1 gigahertz. So we have an unlicensed spectrum in France, in Europe mostly, in 333 megahertz, 333 megahertz. But this band is pretty saturated now, because you have all the remote control and so on working in this kind of band. This kind of radio works in the 868 megahertz. So you have some, let's say, several megahertz of bandwidth between 665 megahertz and 670 megahertz. So this is the band where we are going to use, and this is unlicensed band.
It makes any sense to think about SMS messages as another way to communicate, because now there are some approaches that can use SMS.
I agree with you, but still, SMS means that you have a 2G system, SIM card and so on. If you look at the consumption, you're not going to have a consumption of, let's say, 20 milliamps. You're going to have a consumption of 200 milliamps, so at least 10 times more. So you're not going to run on a battery for a year, like 4 AA battery like this. Not for a year if you're using SMS. So this is completely different. But if you want to use SMS, you can, on the gateway, put a 2G shield that sends SMS instead of uploading it to the cloud. You can do it if you want. And another method that might be more cost effective is to upload the data to the cloud and then have an application that take data from the cloud and then send SMS from a computer. That is more cost effective if you really want to use SMS instead of other kind of interaction. Yeah, okay? One more question?
What about the ESP8266 platform? I think it's the cheapest.
The what?
The ESP8266 controller. I think it's the cheapest Wi-Fi enabled microprocessor, which only costs €1.50. But of course it's not long range, it's just Wi-Fi.
Yes.
But I think it's the cheapest way to build an IoT thing.
That's the issue. Wi-Fi is like 300 meters range.
Yeah, of course, yeah.
And the consumption is much higher. The consumption is about at least 100 milliamps when you're transmitting. Of course, the throughput is a little bit more, so you spend less time in transmission. But still, you have a lot of beaconing system with the access, with the base station, that actually makes your Wi-Fi system consuming more. Here you have a very simple, you don't have association and so on. You have a very simple system. When you want to send something, you just send it, and then the gateway will get it. No association, no, SSID, passphrase, and so on, that are related to Wi-Fi access. So, apart from the range advantage, you also have the simplicity advantage of this kind of radio. That okay? Should we move over there?